So, good afternoon, everyone. My name is Dan Peer. I'm a professor here at Tel Aviv University and also the Vice President for Research and Development. So, Vice Chairman of Tel Aviv University Board of Governors, Honorary Doctor and long-standing Governor and friend, Sami Sagol. Chairwoman of the Board of Governors, Daphna Meitar Nechmad, President, Professor Ariel Porat, governors and guests. I'm delighted to welcome you to the festive ceremony inaugurating the Sagol Center for Regenerative Medicine at Tel Aviv University. Sami and his family has become icons at Tel Aviv University. When Sami dreams, he dreams big. Through his deep and unique commitment to the development of the university, Sami created the Sagol School of Neuroscience, an original model for interdisciplinary research, which has propelled us to become one of the leading universities in the world for brain research. That would have been a great accomplishment by itself for most people, but Sami's curiosity and visionary philanthropy continues to venture into magical world of regenerative medicine. This widely developing field is one that we at Tel Aviv University have contributed to enormously. Thanks to Professor Tal Dvir and other brilliant breakthroughs that have become, and now with the establishment of the Sagol Center for Regenerative Medicine, Sami is enabling us to accelerate and broaden our research into this exciting field. I have no debate that as a result of Sami's and the Sagol family generosity, we will be able to have a very impressive impact in the future of global health. I would like to invite Tel Aviv University President, Professor Ariel Porat, to say a few words.
Okay, so Sagol family, Sami, I understand that Tova unfortunately isn't here with us today, but there are Itzhak and Linda and Yossi and Shirley and Liat and all other Sagol family members are here with us today. And of course, all the other guests and governors, deans, vice presidents, of course, Daphna Meitar Nechmad, our chairperson. And this is a very special occasion for me. You know that the last month was a kind of a Sagol festival here at Tel Aviv University. You might know that just about a month ago, we inaugurated here together with Mike Bloomberg and Yossi and Shirley Sagol, another wonderful initiative of Sagol Family, which is our new city leadership program, Bloomberg Sagol City Leadership Program. The inspiration comes from the Bloomberg Harvard City Leadership Program, and it's going to happen here at Tel Aviv University starting October this year. But today we are celebrating a fantastic initiative of Sami, of course supported by the entire Sagol family. The initiative is Sami's initiative, and this is the Center for Regenerative Medicine. You know, when I entered the office 3 years ago, the first laboratory that I visited, number one, from then I visited, I don't want to say hundreds, but many, many dozens of laboratories. But the first one I visited was Tal Dvir's laboratory. It was immediately after this breakthrough with respect to the three-dimensional printed heart, and I wanted to see it in my own eyes. And of course I was amazed by what Tal and his staff had done there. You know, there is another new breakthrough of Tal and his staff with respect to the spinal cord, and it took me a few weeks to understand that, first of all, that this is regenerative medicine. I didn't know the word before. And more importantly, I learned who is the one or who is the family that supports most of or much of what Tal Dvir does in his laboratory, and this is, of course, the Sagol family. So even though today we are celebrating a kind of a marriage between Sagol family and regenerative medicine, I think at that time it was more kind of a flirting with the area. But yes, Sami, as always, as it did in many times in the past, could predict the future many years before others. So what is this center of what is regenerative medicine? So many people here know much better than me. So I wouldn't go into the details, especially not to, to embarrass myself. But regenerative medicine is about repairing and regrowing of tissues and organs damaged by, could be by trauma, by disease, or by age. And the center we are inaugurating today would have two main components. One component is education and teaching, and the other one is research. Let me say a few words about each. So first of all, with teaching and education, the idea of the center is that doctors, that graduates of the medical school of Tel Aviv University would have knowledge in this very futuristic area of regenerative medicine. So we are going to have courses dedicated for regenerative medicine that students in the medical school would take during their studies here. No less important, we are going to have a special track, MD PhD track for regenerative medicine. And this is the way to make Tel Aviv University the center, the most important center in that area in Israel, and I believe that in few years it would be top in the world. We were very lucky to have Benny Deckel that we stole, well, not fully stole, but took from Sheba, and he would be the one who would run the center together with excellent faculty at Tel Aviv University. I mentioned Tal Dvir, but many others from both the medical school and the Faculty of Life Sciences. Of course, they all would be involved. So this is one component. And the other component, of course, is research. So the center would enable us to have top-of-the-art equipment, laboratories, and something which is very important. I know how important it is to Sami. Moshik, you are missing something. Be careful. So we are going to have collaborations, international collaborations. You know that for Tel Aviv University, international collaborations is a very important issue generally, and in this area it would be especially important, and the reason is, Sami, correct me if I say something wrong, but the reason is that we still be a leader in this field, and we want to learn from top universities, Harvard, MIT, Stanford, and some other places. At the moment, they do better than us in this field, but not for long. That would change. So, So this is one type of collaboration that the center would be involved in. The other type of collaboration is with hospitals. We have Ronnie, my friend Ronnie Gamzo here, representing the hospitals here. I think that Arnon is here too. So, and Iris is, half here, half there. So there are people here from both Sheba and Ichilov. I don't know if there are people from Rabin, but hopefully, Anyway, it's both the people from Sheba and the Asaf HaRofeh, of course. Shai Efrati, the renowned Shai Efrati, a leader in his field. So as you know, most people from the hospitals knows that now it's a top priority for Tel Aviv University to deepen collaborations and research with hospitals. We are now in the process of establishing centers in Ichilov, Sheba, and hopefully also Bellinson. With Ichilov, we have already done it, the gene therapy, and we'll have other centers, and definitely regenerative medicine would be a very important area in which we could collaborate with hospitals. So this is about research very briefly. Now, as Danny mentioned, Sami and the Sagol family, but Sami in particular in this area, has a kind of ability to predict developments in sciences before many others. And it has been mentioned, everybody knows that Sami is renowned mostly for this, at Tel Aviv University, mostly for the Sagol School of Neuroscience. Just a couple of months ago, I gave a lecture at the Israeli Academy of Sciences where I am a member. And the lecture was about academic freedom. And among other things, I mentioned or raised the question, and I asked a question about the potential tension between donations and academic freedom. Right? You could imagine that universities that do not know how to lead themselves rightly might take routes or directions which are not necessarily the optimal, because donors might offer them those opportunities and they might be tempted not to do the right thing. Of course, this is our responsibility, and all the people here, many of them are fantastic supporters of the university. They encourage us and promote research that we really want to do. But at that session, when I lectured about academic freedom, I gave the Sagol family, and Sami Sagol in particular, as a counterexample. I say sometimes donors predict before academic leadership predict. And we should listen to them very carefully. There are other people here, Jeremy Kohler, and others that did the same thing in different fields. I think Jeremy also is a kind of a person that could predict the future before many others. But I gave the example of the Sagol family in Sagol School of Sciences. And the Sagol School of Neurosciences. Neurosciences and Sami Sagol, these are synonyms in Israel. And not only in Israel, anyway. When I travel in the world and I meet presidents of universities and top scientists, everybody knows Sami Sagol. When you speak about neuroscience, when you speak about aging, Sami Sagol, this is the person that everybody knows. So Sami, with his vision, brought Tel Aviv University to have the wonderful Sagol Neuroscience, School of Neuroscience, and then he did the same thing in other universities, and this is an achievement that we should all remember. For me, Sami is the one who have made me really thrilled about neuroscience, about regenerative medicine, and about aging, but actually more generally about life sciences and medical research. I have many, many Sami hours. Many, many. I also have some Yossi hours. Where is Yossi? Yossi hours. But many, many more Yossi, many more Sami hours. And as I said, he was the one that really inspired me and inspired many people around me. And as I said, he inspired also many, many people outside of Israel. Sami, that there is a kind of a personal commitment here. It's my responsibility that in a couple of years and even earlier, you will be extremely proud of the center we are inaugurating today. So I want to tell you, Sami, that I'm very proud to be your friend, if I may say so. In a way, also to be your student in a very specific way. I'm very grateful to you, to what you, together with your wonderful family, the Sagol family, what you did for science. I'm really grateful to you what you did to, as I say, science generally, but actually to humanity, to the well-being of humanity. So it's a great honor for us to have you as such a major partner, you and your family, as such a major partner at Tel Aviv University. Thank you very much. This is to witness. Okay. This is to witness that on the 30th day of May 2022, the Sagol Center for Regenerative Medicine was inaugurated by Sami and Tova Sagol, thereby pioneering the study and research of regenerative medicine at Tel Aviv University and its affiliated hospitals, training the next generation of talented physicians and researchers to lead and shape this cutting-edge field, advancing integration of novel technologies for restoring diseased and injured tissues and organs into medical practice, promoting robust collaborations with leading institutions worldwide, reinforcing the long-standing commitment of the Sagol family to the advancement of Tel Aviv University, and strengthening the impact of Israeli science on elevating suffering and saving lives. Ariel Porat, Mark Steif.
Thank you.
Okay. סמי, תרצה לומר כמה מילים?
כמה מילים.
Okay. The floor is yours, Sami.
Thank you. Thank you very much. It was a little confusing and embarrassing to hear so much about myself. I'm still young. I still have a future, so I must be careful. I am really proud that I can really initiate ideas like regenerative medicine into the school of doctors, of medical doctors. We are discussing it that in science, people have time to do research, to think, to rethink, etc. And doctors don't have this kind of opportunity. They are working very hard. They are committed not to do any harm, so they are very careful. They don't dare to jump too high. And this may be really, instead of helping the patients, it may stop helping them. So I thought of the idea of saying, maybe we start a new medical school for young students, especially capable in research thinking, and research disciplines, to be doctors and researchers. Of course, the first thing is that we need budgets for this. And I am promising you, I am only the start of this regenerative thinking. Billions are going to come into this field because it's needed. And a lot of governments, businesses, capital is going to flow into this. And this is looking into the future, how important it is that doctors should be trained on advanced sciences. They should have the time to study and learn, and still be careful when they are applying it to people, human beings. So this is just a start. And I hope we'll see a fantastic future in the very near time. And I have some friends here who are my age, 80 plus. These are the leaders of this new patients. And once we'll see this fantastic change in the 80-year-old plus, 90-year-old plus changes, big funds are going to flow. I expect Jeremy, when he gets older, he will understand this. So not everything is about business development and business administration. Also medicine and life sciences is going to be a fantastic place to invest. So thank you all. Thank you that you are taking the leadership in this, and a lot will follow. Thank you.
Okay, thank you, Sami. I want to invite Professor Ehud Grossman, Dean of the Faculty of Medicine, to say a few words.
Good afternoon, dear Professor Porat, the President, Professor Daniel Peer, the Vice President for Research Affairs, Professor Azem, the Dean of the Faculty of Life Science, Professor Benny Deckel, the Sagol family, staff members and guests. It is my pleasure to inaugurate today the Sagol Center for Regenerative Medicine in Tel Aviv University. In recent years, medicine has advanced dramatically. With the knowledge of the genetic code, it is possible to diagnose genetic mutations that cause diseases. We practice personalized medicine to tailor individual treatment according to genetic characteristics and biomarkers. We improve dramatically our understanding the immune system, and immunotherapy became a very efficient tool for treating a wide range of diseases, including malignancies. Use of artificial intelligence improved remarkably diagnostic techniques. However, only recently, during the global pandemic, use of new messenger RNA technology has made it possible to produce in a short time a vaccine to stop the pandemic. Unfortunately, in one major area of organ replacement, progress has not been as expected. The predominant clinical strategy today for organ replacement is organ transplantation from donors. The principal challenges are the availability of donors on organs and the need for immunosuppression, which have side effects. Unlike the current clinical strategy that focuses primarily on treating the symptoms of a sick organ, regenerative medicine seeks to replace tissue or organs that have been damaged. The tools used for this purpose are tissue engineering, cellular therapies, medical devices, and artificial organs. Regenerative medicine is a relatively new field that brings together experts in biology, chemistry, computer science, engineering, genetic medicine, robotics, and other fields to find solutions to some of the most challenging medical problems faced by humankind. The concept of regenerative medicine is restoring structure and function of damaged tissue and organs. The goal of this approach is to find a way to cure previously untreatable injuries and diseases. Sami and his family, who are great supporters of medicine, are always creative and come with new ideas. Sami saw the potential in regenerative medicine and generously decided to establish a regenerative medicine center in Tel Aviv University. The purpose of the center is to promote research in regenerative medicine and to train a generation of researchers and physicians who will practice regenerative medicine. The Faculty of Medicine will integrate regenerative medicine into the curriculum, and the center will encourage, by grants, students of medicine and life sciences to be engaged in research in this field. Together with Sami and the family, we believe that in less than a decade, we will be able to see a new generation of researchers and physicians who practice regenerative medicine. And thanks to the advance in the field, we will be able to prolong life and improve life quality. I take the opportunity to thank Sami and the family for the generous donation, and I wish them a long and healthy life. I hope that they will see the fruits of their donation and that they will be able to continue supporting medical research and education. Thank you very much.
Okay, I now invite, thank you, Professor Grossman. I now invite Professor Benny Deckel, who is the first head of the Sagol Center for Regenerative Medicine.
Professor Porat, Professor Grossman, Professor Peer, Sami, Sagol family, everyone. I want to tell you a personal story. So, my son got ill 2 years ago. And as a parent, you don't sleep, you don't drink, you worry all the time, and you think about his problem. So what do you do as a doctor? You go read the medical literature, right? You go into the New England Journal of Medicine, you go into JAMA, the British Medical Journal, and Lancet. And you read these publications and you know them by heart, but they represent the boundaries of medicine. This is sort of the state of the art. It's what Sami said. You can only go to that boundaries and you cannot go behind these boundaries. So that's the doctor hat. So you put on the scientist hat. So what do you read as a scientist? You read Nature, you read Cell, you read Science and the biomedical and the subspecialties. And once you read these publications, you start seeing the gap. Okay? You start seeing the clinical biomedical gap. So you want to treat your son with what is written in Nature journal, but you can't because you have this ethical boundaries. You're not allowed to, of course. So what Sami does, and Sami and his family, they want to close this gap, this clinical research biomedical gap. And Sami, I want to thank you for that. He wants to bring the doctors and the scientists to the table, right, and support that interaction. And I love that. He wants to close the gap in regenerative medicine. And I also love that because I think that's the future of clinical medicine. We want to generate new cells, we want to generate new tissues, we want to generate new organs to regenerate, or maybe be more humble and just repair them. That would give us more mileage along the road. I mean, we can travel with our car more. So that's the essence of regenerative medicine. He also want to train the next generation of researchers and physicians, scientists. We have such huge human resource here. They're fantastic, and we want to push them forward to be the next, they're the brightest. We want to make them make the discoveries that will allow the regen med flourish. Now, one example of the Sagol Center activities would be, for instance, to grow your own organ in a petri dish. We can do that nowadays. We generate organoids. You take some cells out of your body, you put them in a petri dish, and they mimic what an organ looks like in vivo in our bodies. And of course, these organoids can be transplanted back into you and generate a new organ, regenerate, and make new, regenerate, rejuvenate. But most importantly, you can test many drugs, many new drugs on these organoids outside of your body. And this is really neat. This is really exciting, this organoid medicine, which is going to be part of the Sagol Center. And I think this is sort of the research that can close the gap. If you're ill, I would advise you to have your organoid in a petri dish and check the most sophisticated drugs on your organoid to close the gap, to get these drugs into clinical medicine. And this is what I'm going to do with my son. I'm going to try to close the gap, and I wish you all, really, thank you so much, and I wish us all a big success in this center. Thank you. Karikó? So now I'm really excited to present Katalin Karikó. Now I have another story about Katalin Karikó. I had this student, Lior Zangi. It's again a personal story. He did his PhD with me, and then he did his postdoc with me, and then he went to Harvard. And in Harvard, he started using modified mRNA for heart regeneration. Katalin. Not, I work in the kidney, so I said kidney. And interestingly, he calls me up and he says, you know, there's this lady, Katalin Karikó, she is going to change the world. Now, he said that, I would say, about when he started his postdoc in Harvard with Ken Chen. It was, I don't know, about 10 years ago. And I would tell him, you know, what is modified mRNA? So he explained to me, you know, he went and showed me the immunity paper, you know, the fabulous immunity paper, which is so cool. And, you know, this immunity paper, Katalin, changed the way we practice medicine all over the world. We have her mRNA, modified mRNA in our bodies. And another small story, on Friday Eve dinners, I would ask people, you know, there was the Corona period, you know, I would say, let's make a quiz about Corona figures. So everybody heard about Anthony Fauci, of course, and many local heroes here in Israel. And I would say Katalin Karikó, and no one knew that name. Who is Katalin Karikó? But now, Katalin, everybody knows your contribution to the world, and I wish you all the best. Thank you.
Thank you very much. Good afternoon, professor, guests. I used to be in the laboratory and not giving talk like that, and but I try my best to be not too scientific. And I have to tell you, I grew up in Hungary in a small town. 10,000 people lived there. My parents had no formal education, just elementary school education, but they emphasized the importance of it. And thanks to my wonderful teachers, my parents, and so I am here. I wouldn't be here, of course, if I wouldn't be terminated in my position several times. And so the lesson is that whenever something is a bad news, you have to figure out what good you can come out of it, how you can come. And I worked at Temple University of Pennsylvania for 24 years. I worked at University of Pennsylvania 24 years on mRNA. But when my colleagues introduce me to somebody, they always say, oh, meet my colleague, her daughter is 2 times Olympic champion. They never said that Kati is working on mRNA. But things changed. My daughter works for TriLink, who makes the cap analog if you get the Pfizer vaccine, works for that company. And now that when she introduced, you know, they say her mother is Kati Karikó. So RNA was discovered 60 years ago, and I gave a lecture yesterday about what happened during these 60 years. And I can tell you that the Regenerative Center, half of it will be mRNA producing section, because the mRNA, this nucleoside modified mRNA, as we heard, it will be used for many treatments. And I also participated some of them, but discovering our paper, 2005, it took like 5 years. And the first paper, when they used it, actually, it was producing the Yamanaka factors, which helped to make stem cells from anybody's cells. So they showed it that when you take out a cell in any of the cells and human cells, they can make it back to stem cell. So you don't need a blood cord kind of cells. Cells can be made from your own cells, and then it can be differentiated in different types of cells, which you might need. So that's not for the organ, what we mentioned, but for cells. And I myself, I wrote a grant. I established the company together with Drew Weissman, and we had the patent, and it was RNARX. You never heard this company. We didn't get the patent for our own company from university. So, but we wrote a business plan for erythropoietin coding mRNA, which can generate red blood cells. So if somebody has anemia, can take the mRNA, a shot of mRNA, and that erythropoietin will help to get red blood cells. And of course, if you are training for bicycle race, then you don't think about that using EPO because it is dangerous. But when I was doing this messenger RNA, and I could see that it will be good for so many things. And one of them was I generated messenger RNA for telomerase. What happened is when we are getting older and older, the tip of our chromosome as the cells are dividing gets shorter and shorter. But now that what we could do, and we showed in the culture cells, that we can extend the tip of the chromosome by delivering telomerase and guide RNA for that. And why it would be good for regenerative medicine? For example, older people can give bone marrow because it can be treated, and then more cells will be available for relatives and others. So that's also which right now there is a company in United States, and RNA specializing, and they licensed it to have extended telomerase. What I did also was an experiment to use TGF-beta. I am saying this word just, for the colleagues here. So TGF-beta 3 was discovered at University of Pennsylvania, that how you can have scar-free wound healing. So they discovered that the onboard baby, when they operated on in Edzik did in the University of Pennsylvania, when they cut the babies, and they did operation, there is no scar. So maybe the ladies who want to do some surgeries, and important not to see any scar, could be important. You already mentioned Lior Zengi, who did 2011. He published with Chen in Harvard, injecting nucleoside-modified mRNA to the heart. They did this experiment in mice, and they showed that it was DNA or it was conventional RNA. Then it was very dangerous, but when modified RNA was injected, it was good. I have to tell you that this went on to human trial. So it was injected, this nucleoside-modified RNA, the same as you get if you get the vaccine from Pfizer or Moderna, BioNTech, Pfizer, and Moderna. And this modification was present and injected in 2018, already started trial. One trial that during bypass surgery, the patient's heart directly was injected with this mRNA. This called for VEGF-A, which is translated to a protein, generate new blood vessels. And in this January, when they looked at the data, they decided to proceed because those patients with heart failure performed so much better than those who were just injected with the conventional placebo. So this is what all of us thought, that this will be the first mRNA therapy which will be approved by FDA. So it's starting a phase 3 trial. And also the same mRNA, VEGF-A mRNA, was already used in clinical trial to heal wounds, which was diabetic necrotic wounds, which maybe some you might have. Or now that there is a solution for that in clinical trial, so we have to wait for the outcome. Colleagues in Japan, because people didn't know that there are mRNA in all over the world. There are companies in Japan, in Korea, and in the US specializing, and not just in Germany, for mRNA use. And in Japan, for example, they use mRNA to generate cartilage, new cartilage. That's, again, I would need some, you could see that I walk slowly because my knees hurt. So that when cartilage from the end of the bone is worn away, that we can replace by local injection of mRNA. Etris, other German company working with mRNA, they reported an animal trial that used bone morphogenic protein coding RNA injecting. So that would accelerate healing of the bones. And maybe, for tooth replacement and other things could be used And these were animal studies. BDNF, which is a brain-derived neurotrophic factor, was also used actually in Japan. They used it to improve and regenerate neurons. A big field, if changing the genome when there is some error in it, is a Cas9 mRNA, which is actually was a clinical trial was used recently, and the report came out recently, is from Intellia, a company in Boston. And what they used, there was a patient who, there are patients who had amyloidosis. Their liver is producing a toxic protein wrongly folded, and that's very toxic. And after diagnosing somebody with this disease, 5 years later, usually they are dying. And what they did, they delivered an mRNA, nucleoside-modified RNA coding for this enzyme, which could, with the help of the guide RNA, could find in the liver that gene which makes this toxic protein, and they could turn it off. And after 1 year, those 3 patients who get the highest dose, and that's just one injection. And then they went home, and then 1 year later, still they are not doing the toxic, not making the toxic protein. So again, just the imagination of the scientists and reaching out to use the RNA. And in immuno-oncology, of course, the RNA used for generating the T cells. These are CAR T cells. This is a chimeric antigen receptor having this T cells. The antigen receptor is an antibody, and it is helping the T cells to find those bad cells had to be killed. And this is one way to eliminate cancer, but many of the antibody, many of the protein on the cell surface is shared. So it is good if they use RNA, because it is temporally. And of course, then Pierre, here, you have here in your university, who is doing, and for me, from the day one, even 10 years ago, seemed that the solution for the future will be how you formulate the RNA. So it has to be, if you put a RNA on the surface, some kind of molecule which will target in specific cell type, specific organ, then you can do many of the medicine, many of the treatment which is already FDA approved and practiced, but they had to take out your cells in culture to treat, put it back, and which is a $1 million treatment. And now you can do in vivo. Then we'll put, and his team, put on the surface target molecules, which will help to find in your body those cells which had to be expressed, those coded mRNA, which will be inside the RNA inside this formulation. So the future is relay with this. I can tell you on and on, that how many things can be done, but I can mention also at present what cannot be done, but maybe, you are listening somebody and come up with idea, because I will be the last person to tell somebody that cannot be done. I heard so many times. And so, right now the problem is that we cannot reach deep tissues. So when we delivered intrathecally, so the CSF, the injected any kind of RNA, usually only just the cells which is lining the cord, for example, could pick it up. And it won't go through the layers of cells, and it won't go through and find, the neurons in your middle of the brain, something sometimes we should need to fix. But right now, it won't go through mucus. So when we inject it intraperitoneally, there is also a clinical trial starting when messenger RNA coding for transcription factor, which can change certain macrophage to be an attacker macrophage for women who had ovarian cancer, which is not a solid cancer, but it is all over in the intraperitoneal area. And this is actually the company just presented in a RNA meeting, which we attended with Dan, and they just presented. This company was Tidal, a small company, and $500 million was purchased by Sanofi. So we will see that more RNA coming for therapeutic, for oncotherapeutic. And so these kind of approach is already tested, and animals study, and many of them human trial. But as I mentioned, right now in deep tissues, in neurons, we cannot reach those cells. But we can reach so many others, and maybe this, a year or two from now, somebody will say and stand here and will say that, yes, we can reach this neuron, Kati was wrong, but we made this. And so I wish for the center a lot of success. And as I mentioned, part of it will be an RNA research here, and will be very successful. And it's a very great thing that that you have this center, and the scientists and the physicians will come here and learn and invent new things. Thank you very much.
Okay, so thank you, Professor Karikó. And once again, congratulate you on your well-deserved honor last night. So we now have a beautiful musical interlude for you. I invite sopranos Ya'ara Atias, Yael Shoam, and Chen Wein, students of the Buchmann Mehta School of Music, with Dr. Uri Rom, head of the Buchmann Mehta School of Music, to perform. Thank you.
Good afternoon, Professor Porat, dear Mr. Sami Sagol. When I was contacted by the organizer of this event and asked to supply music for the ending of this wonderful ceremony, we are just over there at the Buchmann Mehta School of Music. I had the idea in less than a week's time. We are traveling to Dresden, Germany. It's 5 students of the vocal department, the head of the vocal department, Professor Sharon Rostov-Zamir, and myself. And I thought that we could present to you some of the program that we're going to do there. So we put together a very short program and very varied one. And so we're starting from classic, and you'll discover everything in due course. So let's start with Mozart. I invite on stage Yael, where are you, Yael? To sing the Spina from Così fan tutte. You might know the opera. The Spina is the maid, and she's addressing her 2 ladies and telling them, men and soldiers' fidelity, forget about it. All men are made of the same pasta. So let's encourage Yael.
In uomini, in soldati, sperare fedeltà. In uomini sperare fedeltà. In soldati sperare fedeltà. Fedeltà, fedeltà. Non vi fate sentir per carità. Non vi fate sentir per carità. Di pasta simile son tutti quanti, le fronde mobili, laurei costanti, abio del uomini, stabilità, menti de lagrime, fallaci sguardi, voi ingannevoli, vezzi bugiardi, sono primarie lor qualità, sono primarie lor qualità, e noi non amano che lor diletto, poi ci dispregiano, neganci affetto, ne va da barbari chieder pietà, ne va da barbari chieder pietà, chieder pietà, chieder pietà. Paghiamo femmine d'ugual moneta questa malefica razza indiscreta, amiam per comodo, per vanità, amiam per comodo, per vanità, amiam per comodo, per vanità. La
Thanks a lot to Yael. Now, one of the kinds of repertoires you don't very often get to hear in Israel, I don't know how it is in the US and Canada and around the world, is German operettas of the 19th century. Now, this is a wonderful repertoire, and I was very prestigious to conduct some of these well back in Germany when I spent there 15 years in Berlin. And now we are actually accessing one of the most beautiful and well-known operetta numbers from Judita by Lehar, who also wrote the Mary, the Merry Widow, and this is a very luxurious, very sensuous music of the main character, Judita, a gypsy woman, and the text says everything. Meine Lippen, sie küssen so heiß, my lips, they kiss so hotly. So I invite Yara to make this sound.
Ich weiß es selber nicht, warum man gleich von Liebe spricht, wenn man in meine Nähe ist, in meine Augen schaut und meine Hände küsst. Ich weiß es selber nicht, warum man von dem Zauber spricht, der keiner widersteht, wenn mich sieht, wenn an mir vorübergeht. Doch wenn das rote Licht erglüht, zu mitternächt'gen Stund, und alle lauschen meinem Lied, dann wird mir klar der Grund. Meine Lippen, sie küssen so heiß, meine Glieder sind schmiegsam und weiß. In der Stirn ist geschrieben, du sollst küssen, du sollst lieben. Meine Füße, sie schweben dahin, meine Augen, sie locken und glühen. Und der stürzt wie im Rausch, den ich weiß. Meine Lippen, sie küssen so heiß. In meinen Anden drin, da rollt das Blut der Tänzerin, denn meine schöne Mutter war des Tanzes Königin im goldenen Alcazar. Sie war so wunderschön, ich hab sie oft im Traum gesehen. Schlag sie das Tambourin zum wilden Tanz, da sah man alle Augen glühen. Sie ist in mir aufs Neue erwacht, ich hab das gleiche Lust. Ich tanz wie sie um Mitternacht und fühl das eine bloß. Meine Lippen, sie küssen so heiß, meine Glieder sind schmiegsam und weiß. In der Stirn ist geschrieben, du sollst küssen, du sollst lieben.
Thanks, Yara, with Judita from the operetta Judita by Lehar. And one thing that singers need to do all over the world is sing in many languages which are not their mother tongue. And actually, we have only one song in Hebrew today. So now we're actually moving to France, actually to a German composer. And Jacques Offenbach, no? Actually, no, we moved to Menotti. So Menotti is an Italian composer, but he wrote in English, and this is the comic opera, The Telephone. So we have Lucy, who is actually addicted to this then very modern gadget, and she talks on phone all the time, although at the very time that this scene takes place, a tenor is trying to offer her marriage. She prefers the telephone. So let's hear Chen with Lucy from The Telephone by Menotti.
Excuse me. Hello, hello. Oh, Margaret, it's you. I am so glad you called. I was just thinking of you. It's been a long time since you called. Yes, you already told me that. No, my darling, of course I won't forget. Yes, yes. Goodbye, my dear, goodbye. Yes, my darling, goodbye. Yes. Uh-huh. That's the funniest thing I ever heard. And how are you and Bets and Bob and Sarah and Sam? You must tell them that I send them my love. And how is the pussycat? How is the dog? Oh, I'm so glad. Goodbye. Yes, Margaret. All right, goodbye. All right, goodbye. Now, Margaret, goodbye. So long. That was Margaret.
Thanks, Chen. And now we are moving to France, to Jacques Offenbach, actually the son of a Jewish cantor from Cologne, from the Cologne synagogue, who immigrated to Paris and actually created French operetta. And his most substantial work is, of course, Les Contes d'Hoffmann, the Tales of Hoffmann. And we are taken now to the Grand Canal in Venice, actually, where the second act starts, and we hear a barcarolle, that's a song of two gondoliers just cruising across the Grand Canal.
d'amour, souriant aux ivresses, nuit plus douce que le jour, ô belle nuit d'amour, ô belle nuit d'amour, souriant aux ivresses, nuit d'amour, belle nuit d'amour.
Okay, I'll grab this. Probably the most famous musical of all times, The Sounds of Music, Roger and Hammerstein, needs no introduction. My Favorite Things, with Chen.
Raindrops on roses and breathing on kittens, bright copper kettles and warm woolen mittens, brown paper packages tied up in string. These are a few of my favorite things. Cream-colored ponies and crisp apple strudels, doorbells and sleigh bells and schnitzel with noodles, wild geese that fly with the moon on their wings. These are a few of my favorite things. Girls in white dresses with blue satin sashes, snowflakes that stay on my nose and eyelashes, white paper packages tied up in string. These are a few of my favorite things. When the dog bites, when the bee stings, when I'm feeling sad, I simply remember my favorite things, and then I don't feel so bad. Raindrops on roses and whiskers on kittens, bright copper kettles and warm woolen mittens, brown paper packages tied up in string. These are a few of my favorite things. Cream-colored ponies and crisp apple strudels, doorbells and sleigh bells and schnitzel with noodles, wild geese that fly with the moon on their wings. These are a few of my favorite things. Girls in white dresses with blue satin sashes, snowflakes that stay on my nose and eyelashes, silver white winters that melt into spring. These are a few of my favorite things. When the dog bites, when the bee stings, when I'm feeling sad, I simply remember my favorite things, and then I don't feel so bad.
And as promised, we conclude with a song in Hebrew. This is something that we are going to perform next week in the Dresden Synagogue, in the new synagogue, which was erected just next to the historic site of the synagogue, the Dresden Synagogue, which was, of course, destroyed in the Kristallnacht in 38. And this is the flute. A wonderful song to words by Leah Goldberg. The music is by David Zehavi. The flute, it sounds so gentle to the heart. Hechalil, with Yael.
פשוט ועדין וקולו כמו קול של הלב, כשכשוך הפלגים, כמו שיר ילדים, כמשק הרוחות בפרדס מלבלב, החליל, החליל, מנגינת החליל, לאילן לענן, מנגינת החליל, למרבץ סדרים, מנגינת החליל, לאחי הקטן, מנגינת החליל, להרים, להרים, החליל. המקשיב לא יודע, ידוע היטב, הוא יאיר את הדמי, הוא ירוונו בצליל. כמשק הרוחות בפרדס מלבלב, החליל, החליל, מנגינת החליל, לאילן לענן, מנגינת החליל, למרבץ סדרים, מנגינת החליל, לאחי הקטן, מנגינת החליל, להרים, להרים, החליל. המקשיב לא יודע, ידוע היטב, הוא יאיר את הדמי, הוא ירוונו בצליל. כמשק הרוחות בפרדס מלבלב, החליל, החליל.
Okay, perfect ending. So we are talking about flutes. Yes, the first one. So that ends our ceremony. Thank you all for coming and celebrating this milestone together with the Sagol family and Tel Aviv University. Buses, gate 5, and you can go through the hall. Thank you so much.